You try to use that headphone nearer to your mouth, no?
Yes, sir. Yes, sir.
That will be easier for them.
Yes, sir.
So they can download na dataset from online.
Yes, sir. I shared one .ipnb file. In that there is a link. So after clicking on that link, they can download.
You have shared this IPYNB file.
Sir. In that file, there is a one link.
Okay, okay, okay,
That is a download dataset. There is a this is the link, the HTTP colon. Otherwise, I will say
okay, okay.
from change detection 2014 the dataset is there, na?
Yeah, yeah.
From that. Shall I start, sir?
Okay, welcome back to everyone. Today with us, Kuldeep brother is there. Kuldeep, Monu, and Praful are there with us. They're going to Kuldeep will going to take the lab session, and Monu and Praful will going to help you on the chat if you have any doubts. So the today's code, everything was shared in the canvas. Go to the canvas, and today date 31st August is a folder. Please go to the folder and download that particular code, whatever is shared. From there, it will be easier for you to follow. Okay, Kuldeep, please you can
Sir.
start.
Yes, sir. Good evening to everyone. Good
आवाज नहीं आ
evening.
रहा है आपका.
Good evening to everyone.
Yeah, now it's fine.
Yes, sir. Today we will see the change detection algorithm. So whatever you will learn in this session, that teach by Santosh sir, we will take one experiment from that. For that purpose, we need a dataset for change detection. There are many datasets available for change
कुलदीप थोड़ा
detections.
आवाज का इश्यू है, थोड़ा आवाज थोड़ा मैनेज कर लेना.
Yes, sir. Yes, sir. Now it is okay, sir.
Yeah. Jyoti Tripathi, he's just started explaining about the data set download and all. He'll going to explain everything. Just please follow the instructions. First, you go to the canvas and download the code, whatever which I have shared. Okay, that then it will be easier for all of you. Kuldeep, थोड़ा mic adjust कर लेना so that it will be easier to everyone.
Yes, sir. Yes, sir.
Okay, please go ahead.
Uh, First, we need the data. There are many data sets from that, like CD 2012, 2014, Davis. There are many data sets available for change detection. So we will take a look on CD net data set that is published in CPA 2014. This is the paper for CDNet 2014, in which they are trying to capture all types of jit, challenges like camera jitter, dynamic background, inter internal motions, shadow, thermal, like that. They are trying to capture. So this is the website for this. You can directly Google CDNet 2014 dataset. So you will get this link. On that link, you can download by this link, that is a dataset 2014.zip. Otherwise, if you want to download only one challenge, then you can download from this, like bad weather.
Slowly, Kuldeep. Slowly,
Yes, sir. Yes, sir.
slowly.
Yes, sir. Uh, like you can download bad weather by clicking blizzard.zip or skating.zip, snowfall.zip. There are different types of weathers. They are captured. So you can download from here also. Otherwise, in .ipynb file, I have shared one link for baselines. In baseline, I have shared a highway.zip. That is, this is I have shared the ipynb file change detection.ipynb. In that, there is a download data set and there is a link like http:// whatever the link is, it will download a zip file. So you can download that, and further we will proceed to uh, on Google Colab. So we will now, this is the part of database. You can download .zip file. We will extract it in Google Colab. So we will now open the Google Colab, new notebook file. Here we will upload our zip file, whatever I have downloaded already. So this is the highway.zip file. You can download in your system and upload it on Google Colab. So upload it. So it will take nearly 5 minutes. So till now we will see what is in that file, something like that. So I will say there are two files in change detection. There is a one directory named as input directory. It is having the input images of from video, like from t is equal to 0 to t is equal to 1000, 2000, like that. There are number of images are there, sequential images are there, and corresponding ground truths for that images are in ground truth folder. All images are not having a ground truth. Some of the images are having ground truth. So that ground truths in which suppose I have ground truth from 800 frames to 1600 frames. So whatever is mentioned in a temporal ROI.txt, there is a one txt file also they shared. In that txt file, I will show. It will look like this. If you extract the highway file, then it is having a ground truth file like this. And for few starting images, they are not providing a proper image, means that is there is no ground truth. After 800 images, they are provided like this ground truth. This is the ground truth for input images. I will show input images. This is the input images. Those are the input images. The objective here is the whatever the changes in present frame from previous frame that you have to detect. So this is, suppose this is the current frame, and in next frame that car is moving. So you have to detect that the motion part. So the main aim is a segment moving objects. This is our main topic for today's lab session. And that temporal ROI file is sharing that ground truths are from 470 to 1700. Like this is the uh, highway.zip folder. So we will see is that data set is uploaded or not. Not yet. No problem. We will start our code by importing OS. Required libraries you can import directly at the time starting, or what whenever you require at that time you can also import. So at this time I need only import OS, so I imported OS. And so we will upload it here as a highway.zip file. So we can extract it by using exclamatory unzip highway.zip highway.zip. This is the command for unzip highway dot zip. So using that, you can extract the whole data from highway.zip. We will wait till it is uploading. L- Let's say we will discuss for chain detection. Suppose I have a T minus 2 image. Oh, sorry. Suppose I have a three images. Like this is a one type of image. Suppose this is a second image, third image. Consider this is a T minus 2 image. This is a T minus 2 image. And this is a T minus 1 image. And this is a Tth image. Means this is suppose this is if this is the second image, then this one is the first image and this is the zeroth image. And I will apply some convolution operations on those three images, and I will find out the what wherever the changes are there in a present image. So it will be stored in a particular one image. So the aim of this is whatever the change in between these three images, that you should reflect in the resultant image. So you can apply any CNN algorithm here. So suppose I have applied one CNN. Suppose I have applied one CNN for this T minus 2. Suppose I have applied T minus 1 is another network, and for T I have applied another CNN operation. And I have concatenated all three image features. And again, I will decode this to my resultant image. So this will be like a encoder decoder problem. So you can use encoder decoder code also here. So for team, you can there are many ways to develop a CNN model. You can concatenate all three images at the time of starting and directly pass to the encoder decoder and calculate the loss for resultant. Otherwise, you can take a three parallel networks for three images and calculate the feature vectors for all three images, and after that features you can concatenate all these three features, and after that decode that features to the resultant. Or there are many ways, or otherwise you can calculate first background for three images, and after that you can subtract that background with the current frame. Like that you can try many ways. Here we are seeing we have a three images, that is a T minus 2, T minus 1, T. T means my current frame, T minus 1 means my previous frame, and T minus 2 means my previous to previous frame. Those three frames I am considering to the CNN network. I have taking a three parallel networks and combining the feature vectors, and I will decode those feature vectors to the resultant one. So we will see that code. Maybe it will be uploaded. Yes, it is uploaded already. So we will extract here the theme of our lab session. I have discussed that one we will do in a implementation way. So this is the uh, what we have extracted our zip folder. Now you can see that uh, at left side it will showing a highway as a folder. It is having two directories, that is a ground truth input ROI BMP ROI JPG and temporal.txt. Like that you have five files, in which two are the directories for ground truths and one is for input images. So Next, we have to list out in a those files in a one variable. So we can first put this in a one variable as a path, input image as a path, input path is equal to highway slash input, that a folder name, and ground truth is in a ground truth folder. So we will put one gt path is equal to highway comma ground truth. After that, we will list out all the path for images, that is using os.list directory, input list, input image list is equal to os.list directory, that is input path. Another is for ground truth. Then whatever the process, for that purpose, we will concatenate all these images like this. Suppose I have this t minus 2 image, then we will concatenate this t minus 2. After t minus 2, we will concatenate t minus 1 image. After that, we concatenate tth image, and after that, we concatenate ground truth image. Like this, 4 images we will concatenate, and it will that we will put in a one train folder. So first we will make here as a train folder. So there is a command os dot mkdir make directory, in which we will make one directory as a train folder. So you can see this is a train folder. It is reflected at the on left side. So we will concatenate all the images from that concatenated images. We will shift in a train folder. We will import CV2 to read images. Import numpy as np for some of the mathematical operations. We require this from matplotlib. Import pyplot as plt to show images. Those are required libraries we have imported here. After that, we will see that a highway in which temporal outward.txt temporal, it is having 470 to 1700. Those images are available for training. So we will take a one for loop for read that images for I in range of 400. We will consider it as a 402 comma This is 470, sorry. So we will consider here as a 500. We will consider it is from 500, 500 to comma 1700 minus 2. So after that, this is for skipping on number of images. So if you want to skip those two images, then you can put two. Otherwise, you want to increase the data set. Like suppose I have images from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 10. Like this, I have a sequence. So I want to consider 1, 2, 3. After that, 2, 3, 4. 3, 4, 5. 4, 5, 6. Like that sequence, if I want to consider, then I will put here as a 1. If I want to skip two images, whatever I have taken, then you can put here as a 3. That is, suppose I have 1, 2, 3. After that, if you want to don't continue those three images, continue from 4, 5, 6, then you can put here as a 3, like that. It is not required. It will directly take from sequence. So first we will read the whatever the path for image required, that we will take in one image path t. We will consider one variable image path t, in which we will put the input image path, that is input path plus whatever I have list in a input image list, that is list having a random images. So we will sort that images by putting a sorted. So we are sorted those images. We will run it again to see how it is going. See, this is the, like these images are there. IN 0001.jpg, 2.jpg, 3.jpg. Similarly, there are for ground truth, that is GT image, and it is like GT 0001, 2, 3, 4, 5, 6, 7, like this. There are the ground truth images are there. So we will put here as a input path. This is ith image. It will be considered from input image list, means starting from 502 to it will be continued till 1698. Similarly, for the, if I want image path for previous image, then it is like I minus 1, and before that image is I minus 2. So we will put here as a 1, and we will put here as a 2. So those are the path for current image, past two images. This is the path. And now we will consider the path for ground truth, that is GT path. GT path plus GT image list. GT image list, and for that we will consider the ground truth for current image, means whatever the present image that is available in a ith position. So we will read those images. Like current image, we will put in a image img is equal to cv2 dot cv2 dot imread. So we will read input image, that is this image part T. We will copy this line and same for previous two images. So this is for T1, this is for T2, and we will name it as a previous one. And for second image, it will be a previous two. So again, after that, we will resize our image to a 256 cross 256. So we can resize that using a cv2 dot resize command. So we will put image is equal to cv2 dot resize, and whatever the image variable that we will put here image comma, and I have to resize it in a 256 comma 256. So this is a 256 comma 256. Oh, sorry, the number 256 comma 256. Similarly, we will resize the image for previous two images, that is for pre1, previous one, or previous two. We will resize. Now we will read the ground truth image. GT is equal to cv2 dot am read, and the image is path is in a gt path underscore t. So we will put here as a gt path, and after that we will resize this image. GT in image, we have a current image, and previous one we have a previous image, and the particular current image having a size 240 cross 320 cross 3. So we will be that resize it in a 256 cross 256 cross 3. Here it will be converted in a 256 cross 256 cross 3. So in GT image also it is starting, it will be a same whatever 240 cross 320, that is size. So it will be again converted as a 256 cross 256. So we will concatenate it in a by using np dot concatenate, np dot concatenate. That is whatever that particularly we will put here as a prev, previous image second comma previous first image comma image comma gt. We will concatenating all these, but concatenating with axis, which axis? Here we have seen I have two axes here, height and width. So I am adjusting it with a width, like my width is increasing. So I will put here as axis 1. So it will be concatenated with a width. So you want to show this image, then you can use a plot dot am show. I take for loop here, show my image, then I will run this. This is a current image. Third one is first one is a previous second image, previous first image, current image, and this one is a ground truth, last one. So like this, we will concatenating all four images, and we will put all those images in a cv2 dot I am right. Some of the participant having a issue for that for loop range 502 to 700 1700 how I have taken. So you can see that highway folder. In highway folder, the ground truths are provided from 470 to 1700. But that's why ground truths are available from 470 frame to 1700 frames. So I have considered here as a 500 as a lower bound. I can also consider 470 also, but for simpliness, I have considered only 500, and the maximum range I have considered as 1700. You can see this ground truth folder. In ground truth folder, for first few images, all are gray images like this. There is a no ground truth labels are available, like black and white image are not available. From 420 from look here, from 470 images there is a ground truths are available. This is the ground truth. So I have considered a 500th image. So this is for all for loop to concatenate all images. So I will write all those images by using cv2 dot write. I will put path here as I have already done train folder slash whatever I have I will be put as a path like string of I, whatever I have for loop that will I consider for image zipping str.i dot z fill. It will be add the sum of the zeros in before the that string ri. I will consider here as a 5 plus dot jpg, and my image is in a I. So run this, then you will see all images will be stored in a train folder. So now train folder is empty, means this is in a processing. It is now in IM. Let's see, this is the our image like this. I have image, whatever I have shown. You can try next image like this, and the corresponding ground truth also. This is the current image, and corresponding ground truth is available on a fourth image like this. So we have done with this pre-processing like concatenation on all. So now we will again shift on deep learning part, means how to develop a how to read all these data, and how to divide and how to process all this data to the network, that we will see in next part, means this session only. Now we will again import whatever we required libraries, that is a TensorFlow, uh, and for display we need a IPython that we can read import. Firstly, I will import TensorFlow. This is the important library to develop a CNN network. And we'll put one path variable. Path is equal to train, because I have all images in a train folder. So I will put here as a train. Okay. So we can read one sample file. Sample image is equal to tf.io.read. This image we will read. So it is in a tensor format. So we will decode it in a JPG format. Sample tf.io dot decode. There are number of files to decode, like base64, BMP, complete CSVGI, but we want JPG. So we will put JPG. And what is the whatever that image I have read in a tensor, that we will call here as a sample image. We will print shape of this sample image dot shape. After that, we will show this image plot dot in a figure mode. Otherwise, you can directly use plot dot am show, and what is whatever I have image, that is sample image. See, this is the image size, that is 256 1024 comma 3. 26 256 means what is the height of that image. 1024 means each image having a width 256. After concatenating four images, it will be size as a 1024. And 3 is the color images. What is the channel size? Now we will do one definition for loading the images. For that purpose, we need what? The path of that particular image. So we will pass here as a parameter image underscore file. This is a we are developing one definition to read images from given path, and it can split by in 4 images. So that we will read by using image is equal to tf dot whatever that sample images we have read, using that read file, read underscore file, and whatever the parameter I have passed here as a image file. So image path we can forward it here. After that we decoded our image. So image is equal to tf dot image dot decode, tf dot image dot decode jpeg image. Now we will find the width size here. We know that is the size of width is a 1024. Still we will generalize that by using tf dot shape. of particular image, that width is present in a first dimension. So we will put here as a 1. And if I want a height, then I will put here as a 0. If I want channels, then I will put here as a 2. So previous image will be in previous second image in a image. Height is I need a height completely, but from width side I need a from 0 to 256 I on. So I will put 0 all for height from 0 to 256, comma all for channels. Similarly for previous one image and current image, we will copy it. This is a previous one, and this is for a current image, but this is a from 256 to 2 into 256, and this is from 2 into 256 to 3 into 350 256, and the ground truth is available. We will name as a real, that is available from 3 into 256 to 4 into 256. Otherwise you do no need to do this. You can cut this, and this is also not required. Okay, after that we will cast all these images. Previous second is equal to tf.cast. We will changing the data type by using tf.cast. That is, my image is available in previous two. So whatever data type you want to use, you can use. That is, I want to float 32. You can use float 32. You can use int 32. But to normalize my image, I want in a floating format. So I am considering here as a float 32. So I will be do it for all four images. That is for previous one, for particular input real image, for ground truth, this is part done for read image from particular path. This is one definition I have put here. So it will return previous two, comma previous one, comma image, comma ground truth. I will put ground truth as a real. After that, I will make otherwise we will test particular this code is running or not. So for that purpose we will run this and whatever I will get previous to previous one image comma real in one variable. So I will put all this here, and I will load image. I will put here load image. So image file path I will put here as a image file path, like path plus I have a path like a train model. I have a path 00600.jpg. I am considering, for example, this. So we will plot this plt.figure. plt.amshow prev 2. Similarly, we will do it for all three images remaining. That is prev 1, image and real. See, all these four images are shown here. It is not showing for previous two and previous one. I think something getting wrong here. tf.float image real. Oh, image having inputs from minimum value and maximum value is 0 to 255. So for matplotlib it should be in a 0 to 1. So we will divide it by 255, and again we will divide it by 255. Again we will divide this image also by 255, and already this real image in a 0 to 1, so no need to divide by 255. So see, this is our input images: previous second image, previous first image, and what is the last one is the current image, and last one is for ground truth. Means our definition is working correctly. So our this load function is working correctly. So we will move towards next function, that is we will do for resizing. Resizing is not required because we already resized that images by 256 cross 256. So resizing is not required now. If your image size is different, then you can resize that by using whatever I shared IPNB file. That you can resize your. We will consider now here as a next to a normalization. So we will normalize our image. For that purpose, we need all these four images: previous two, comma previous one, comma image, comma real. So there are many techniques to normalize. So we are normalizing here our image from -1 to 1 range. For that purpose, we have to first divide particular image with a half of intensity, means of maximum intensity. That is, I have maximum intensity 255. So half of that maximum intensity is 255 by 2. It is means 127.5, and I will subtract it by -1. Then it will be in a range of -1 to 1. So prev 2 is equal to prev 2 by 127.5 minus 127.5 minus 1. Similarly, I will do it for all images. That is for Prev 1. This is real for particular image. This is for previous one image, previous first image real. This definition is only for normalize the image. So after normalization, I will return this. Returning all these four images. This is done for loading images from particular image, and second one is for normalize the image. After that, I will make one a data generator flow. That is like train data gen train dataset is equal to tf dot. There is directly function from TensorFlow to read all these files. Is on the path for that files. That is tf dot data dot dataset dot list all the files. By using list files, you have to put the path here, string path plus star.jpg means but all images. It will list out all the images from train folder. After that, train dataset is equal to train dataset dot train dataset map all images for load image underscore train. We will shuffle our image at the time of training. For first epoch, we will consider all images are going for sequential matter. And in for second after second epoch, we will consider shuffle all these images and again proceed for the training. For that purpose, we need to shuffle these images by some of the buffer size. So we will put here as a train dataset dot shuffle with suppose a buffer size 100 we will considering, and we need a batch size. We want batch size. How much batch size you want to take, you will take. For time being, I will consider here as a batch size as a 1. This is a data generator for what? data generator for training data set. Train data set. And here, why it is not showing? I don't. T8 is set. I will change. This is load image train. Oh, I miss one code here. That is for def load image train, in which I will pass the for particular image path, image file. Then I will pass this to load definition. Whatever I have defined earlier, that I will put here. Previous to returning 4 files, that is previous to previous one, real. 4 images I will get from a load folder, load definition. So for load, I have to pass one parameter, that is a file path. Again, I will pass it to the normalization definition. So this is equals to normalize. It is having 4 parameters. I will return all these 4 images. This is a data generator for training set. We have not considered here as a test data, but we will consider same for testing data generation. So I will put here as a, in place of train data, I will put here as a test data set. I will put same path for testing also. You can make 3 different folders: train data, test data, and validation data. For test data, no need to shuffle your data. Test data, so you can comment for shuffle data, and for remaining you can change as a test data set. You can change path 1 for training, part 2 for testing, and part 3 for validation. Like these 3 paths you can consider. I am considering here as a only one path. For example, I will now first create a generator. You know, uh, I think GAN generative adversarial network is not completed in a session. So I will consider only a autoencoder part for this purpose. And I have shared you a GAN network code. but I will explain only a autoencoder concept now. If you are interested for GAN, then follow the whatever I said, IFI and V file. Otherwise, if you don't want GAN, if you want only a autoencoder, then you can follow the steps whatever I am telling now. For autoencoder, there are two steps are there. One for the encoder and one for the decoder. In encoder part, whatever I shared, this pen file, that whatever I'm explaining, that is a, it is having a t minus 2, t minus 1, t. Are those three images are encoding, and after that encodation, I will concatenate all these features, and again I will decode that image. Am I audible to everyone? I will try to louder. Is it okay now? Okay, thank you. Okay. Uh, Briefly, we will discuss whatever I have coded till. First, we imported our OS directory, OS library to find out the list of that images, list of file like that. And we have downloaded our highway.zip folder from CDNet 2014 dataset. And we will unzip it by using exclamatory unzip highway.zip. After that, we have list out all those images in one variable. Means whatever I have images from input folder and in a ground truth folder, that is in input image list and GT image list. I have uh, sorted that images list out. After that, we will concatenate it, four images. From four images, there are three images are from input folder and one is from ground truth folder. Three, all those three images are like in a sequential manner like t minus 2, t minus 1, t, and the last one is for ground truth. Like that, four images we have concatenated, and those four images are uh, right in a train folder. So after that, um, we imported TensorFlow as a TF, means that library we have imported, and check that library by reading one some sample image. And after that, we have developed one definition, that is to read images from given path and divide that image in a four parts, that is a previous two, previous one, image and real. That is a four images we got. After that, we have done one resize definition that we have not considered here, and one is a normalized definition. So this is a normalize our image from -1 to 1 range. And we have again developed one definition, that is a depth load image train. For that purpose, we passing here as a image file path. That file path we are passing to a load definition, whatever we discussed earlier. After that, whatever images we got, that we normalize by using normalize function, and we returning it, and we developed one data generator for training and one data generator for testing. Those part, data reading part we have completed till now. Now next part is, I have discussed in my first lab session. Our code is divided in four 5 points. That is, one is the data loading, another is develop a CNN module. After that, compile that module and run that module. So first part we have done. That is data loading part. Next part is CNN part, means develop your architecture, CNN architecture. So we will focus on that now. So consider I have input image with I have three input images. Using all these three input images, I want one output image as a binary image. That uh, what uh, whatever is a motion part, that we have to segment out from that those three images. So we require what here? We will consider here as a def to encoder or generator. Anything you can put. I will put here as a generator. So for that purpose, I need three inputs. Input one is equal to tf dot keras dot layers dot input, and the shape for that is 256 comma 256 comma 3. Likewise, I have three images on an input part. Whatever I discussed in a paint format, that I'm copying this. This input one is for previous two. This input one for previous one, and this input three for current image. So we will apply one encoder, convolution encoder, for all these three images. That is by using a convolution operation. So I will, before that, I will generate sorry, one definition, two definitions we will create. That is one for up convolution and one for down convolution. That is by using def downsample how many filters you want, that you can put here. Size of that filter, that is means 3 cross 3 size, 4 cross 4, 5 cross 5, 7 cross 7. Which size you want, that you can pass here filter size. After that, if you want to apply batch size, a batch normalization, then you can use here as a apply bm as a true, otherwise false. So we will here put one f dot sequential f dot case dot sequential. So we will add one convolution layer, result.add, in which we will add tf.keras dot layers dot convert 2D. Whatever the filter size you want to use, whatever you passed by down sample, that you can use here, filters, comma, size of filter. I want to down sample my image, then I will put here stride equals to 2. Otherwise, I have to add one more layer as a max pooling or average pooling. So you can try that. I will use directly stride is equal to 2, and I will use here padding same. Padding equals to same. If you want batch size, then result.add, batch normalization you can add here. Layers dot batch normalization. If you don't want, then it will not go in a if loop. So results dot add. After that, I will apply one activation function, tf dot keras dot layers dot. You can use any activation functions like relu, elu, likirelu. I am using here as a likirelu. After that, I will return that result. This is for downsampling. Similarly, we will do for a upsampling. Same definition, but we will use here as a convert transpose. Convert here we will use the upsampling, upsample, convert to the transpose. Filters are same, size, try to padding. Padding, all these you can add. If you want batch normalization, then same function. If you want dropout, then you can use dropout also. If you want to add activation function, then you can add any other. I am only using same function for downsample and upsample. Here it is showing invalid syntax. Some syntax issue is there. Here one bracket is missing. Similarly, that bracket also is missing in this part. So I will put here one bracket. Done. This is for upsampling and downsampling. So we will stack one, make one down stack and one for up stack. We will do here. One is for down stack. There are many ways to build a model. You can build model before whatever you learn in your lab sessions, yesterday's lab session or day before lab sessions. That can you can use. Otherwise, you can follow this way also. Otherwise, directly you can apply convolution and input one, input two, input three as a input, or to reduce redundancy. I am directly using this type of downsample. Whatever I have used that definition. In that, I will pass 64 number of filters, comma 4, comma I don't want to apply batch normalization, then I will put here as a false. After that, similar type, I will downsample my network 1, 2, 3, 4, 5 times. I will apply batch normalization here. So I will remove that. Place comma after each downsample. Similarly, do one up stack. This is for downsample your images. Means those three images you can downsample. This is for upsample the those for last concatenated features. So if I am here using I will vary the filter size, that is from 64, 128 to 56, 512, 512, 512. You can change it by randomly. 64, 28 to 56, 512, 512, 512. I don't want to use a normalizations. So here as a sample, I will repeat again this process. Just this is for a stack initialization. So after that initialization, we need a last layer having a channel size with a 3. So we will consider here the tf dot eras dot layers dot convert to the transpose mono-2D transpose with I have 3 as a channel size. Filter size I can use anything 4, 3, 2, anything you can use. Stride I will use 2, and padding I will use the same. Padding equals to same. Those are the required parameters. Activation I will put here as a tan hyperbolic because our input is from -1 to 1. So output also it will come from -1 to 1, and that will give range only in a tan hyperbolic. If you normalize your image from 0 to 1, then you can use here as a sigmoid activation function. If you are using any other, means if you are not using any normalization, then you can use a ReLU, or you don't use activation functions like that. So we will consider, suppose uh, one for loop for down sample in down stack. It will consider one by one layer. So x1 is equal to down x1. First we will define x1. What is meant by x1? X1 equals to input 1. That I will put in a variable x1. Similarly for x2 and x2 and for x3. That is for input 2, and this is for input 3. 2, 3. So this will done for downsample. After that we have to concatenate all these three features, that is x1, x2 will be downsample, x2, x3. After that we will concatenate all these features by using tf.keras dot layers dot concatenate whatever the x1 comma x2 comma x3. I got three feature vectors that I have concatenating, which is shown in this figure like this. I have completed this part now. This part I have completed. Means I have read three images, T2 minus 1, T2 minus 1, T, and I have applied three downsampling convolution layers, that is convol 2D, with 5 layers, that is whatever I have used in a uh, down stack. I will show the down stack here. 1, 2, 3, 4, 5, 6. 6 layers I have done for a downsampling. For each T minus 2, T minus 1, T, I have applied a 6 down samples. After that, I have concatenated all those three features. Whatever I have got in x1, x2, x3, I have concatenated all those in x is equal to tf dot keras dot layers dot concatenate. After that, I will decode those concatenated features by using for of in abstract whatever I have defined in abstract. This is abstract defined one. So I will do here x is equal to up of x. For f in abstract x is equal to f of x, right? So whatever I got last image, then I will put that in a last, which I defined earlier. So I will return one model, that is tf dot keras dot model having three inputs, that is in a three variables, that is input 1 comma input 2 comma input 3, input 2 comma input 3, and one output in a x. So I'll put here as a x only. So this is our generator. There is an indent issue, no problem. Abstract. Okay, done. Then this is our generator model. We will put this in a generator. Generator. Sequential, I think spelling it different. This is capital S. So this is the autoencoder part, or you can say as the generator part for GAN. We will print the summary for this generator dot summary. This is what we have done. Whatever it is shown here. So you can follow this, or if you want to plot this, then you can see by using plot tf.keras dot utils dot plot model, in which I will put as a generator. You can see this is the flow for our input, like this. This is for CNN. Now we will see, I will pass one image, and then we will see how it will be your output. Suppose I will concatenate three images, that is input, that is I have image in a previous two. I have to expand one Dimensions tf dot new axis, that will be means it expanded one axis, and 3 dot means for height, width, and column. Same I will do for another two images, that is comma this comma this for current image. It is I think in image it is and this is for a previous one. So I will pass all these three images in a generator. What it is INP. What training is equal to training first false. Whatever we got as a gen output, gen out, we will plot that gen out plt dot. Oh, I will discuss it again. Okay, one bracket is missing. So, okay, like this, we got a output. So again, we will repeat from a CNN part. This is a data loading part we have discussed. So next part is for CNN part. In CNN part, we have done two definitions. That is for one is a downsample and another for a upsampling. In downsampling, we have used parameters as a filters, size, and if you want to apply batch normalization or not, like that you can again use like if you want to use a dropout or not, or if you want to use any specific activation function, then you can pass here as a parameters. Here I have considered only three parameters, that is the filter, size, and batch normalization. So I have put here as a one sequential network. So I have added one convolution layer in this sequential layer. That is a tf.keras.layers convol2d, having a number of filters with size, and considering stride as a 2 means I am dividing downsampling that image. Means if I have an image with 256 cross 256, then after applying this convol2d, I will get a size of 128 comma 128. So after that I will apply here as a batch normalization, and again I will I'm applying here as a leaky rule as a activation function. So it will give as a resultant is a combination of convolution, batch normalization, and a activation function. Similarly, I have done it for upsampling. That is, command is only changed here from convol2d to convol2d transpose. In convol2d transpose, if I have size with 128, 128, then it will get output as a 256, 256. So it will upsample your image and convol. So those are those two definitions we created, that is for downsamples and upsampling. After that, we have developed one architecture for autoencoder having a three input images, that is for input 1, input 2, and input 3. Input 1 is for previous 2, input 2 is for previous 1, and input 3 is for a current image. And we are downsampling those three images by using downstack, and after that downstacking, we concatenated all features whatever we get, and we upsampling those features. And after that we applied one convolution convol transport layers having uh, a channel size as a 3. So here is the process, that is x1, x2, x3 is considered from input 1 2 3, and after that we downsampled x1, x2, x3 and concatenating all these features, upsampling these features, and after that we used that last, means last whatever I have convolution output size, that is a 3 channel size, that we consider here, and we return this model. So we generated here as a one model, means from that generator is equal to generator, and we printed here as a model summary, and we plot here as a model, and we pass here three images to particular our generator having a three images. Which three images? That is the previous two, previous one, and image. All three images we are passing to the generator output. Then generator output, we will get generator output of size 256 cross 256 cross 3. So generator output size is 1 comma 256 comma 256 comma 3. One is for batch size. Whatever I have batch size, I have considered a batch size 1. So 1 256 comma 256 comma 3, I got a output from this. Now we will come towards the loss functions. So we will at that day I have put a loss function directly, means mean square error or mean absolute error. I have put it directly. So now I will today how to build a custom loss function. I will show that. Step generator loss. For this we want what? Generator output and a real output, means y true and y print I want. So I will here put generator output from a target. So created a one definition for that purpose. L1 loss I will calculate, that is mean absolute error, by using tf dot reduce mean. In place of this, I can use directly loss function as a loss is equal to mean square error, that also you can use tf dot absolute target minus whatever I got a generator output. Is a L1 loss. So if you want to add again more losses, like I want to add a, SSIM, or I want to add a age loss, any loss, then you can add here. I will return this loss as a L1 underscore loss. Otherwise, you can return L2 loss. This is a generator loss, means whatever I have used auto encoder. So for that purpose, I have mentioned here as a loss function. In GAN part, follow the IPNB file, and this there is the discriminator part is there. So I am skipping that discriminator part because GAN part is not done in theory session. So directly you come to the cell of optimization. So we will consider only a generator optimization. That is one for generator optimizer is equal to df dot keras df dot keras dot optimizer dot adam. So I am using only generator part. That's why I am not taking a part of the discriminator. If you want to put a checkpoints, then you can put checkpoints. Otherwise, you can skip that part also. So we will see how to show images. So we will generate one definition to show image, generate image. You can directly use a model.fit also. Otherwise, I will show one another method today. Otherwise, you can directly use model.fit, comma, which whatever you want input from data generator that you can use there uh, by using a fit generator. Model, whatever model means generator model. Previous to, comma, previous first image, comma, image, comma, a real image, that is target image. So prediction means predicted from generator. Prediction is equal to model in which I have to pass these three images. So I will get a output like a real output. So our training is equal to we can put training is equal to true or false, anything, no issue. PLT dot figure fix size display is equal to test input 0, our target, that is test input means here as a put zero and prediction of 0. Title is equal to whatever that is image input, comma, second is the target image and predicted image. So we will put this in a for I in range of 3, these 3 images. We will do one subplot, subplot, that is one row, 3 columns, and the which image first, second, third, like this. plot dot subplot. After that, plot dot title. Title are coming from this title, that is title of I. Then plot dot show whatever I have normalized that image from -1 to 1. I will shift it to the uh, normal 0 to 1 range. For that purpose, to multiply my image with 0.5 and add with 0.5. Plot dot show. For example, we will print one comma image comma real in test dataset whatever we taken. That we will pass to this. In place of model, these images are showing like first image is a input image and whatever the target image and the predicted image. Starting before training, we have a random initialization, so it is showing like this. So after training, we will get good output. So we will train this now by step by step. So we will now put a one definition for train step, in which we need how many steps you want, and after that all four images we will pass here, image comma real comma number of steps. So we will define here one a gradient function, that is with tf dot gradient tab. This is the process for train step by step functions. So we will consider here the gradient tab as train tab, and in which I will pass generator out. I will get from generator. For generator, I have to pass three images, that is a previous to previous one and image. So it will give me a predicted output. So I will pass here three images and I will put here training tag as a true. Discriminator part is not there, so I will calculate the loss function. Loss for this gen loss is equal to which function name I have used here for loss, that is optimization may showing that is a generator loss. So I will copy this here as a generator loss. I will calculate loss from a real to a real comma generator output, whatever I got, that I will update in a generator part. So this is part for generator. So after that we will update that gradient, whatever that generator gradient. I will put here generator gradient equals to gen type dot gradient whatever I got loss, generator loss, it will be reflect, it should reflect in a generator dot whatever I have training variables in that. Oh, we will apply gradient by using a optimizer, generator optimizer dot apply gradients, which zip this generator gradient with variables. So this is a part for one step to generate back propagate, one for propagation, one for back propagation. This is for forward propagation and this is for a backward propagation. Then we will go for a fit function. We'll create one fit function in which train dataset, test dataset, and how many number of steps you want that you can put here also. So example previous to comma example, we will take it for testing purpose, comma image, comma real, all are got example image, comma example real. Next. I will explain one more time. Just I will write for step previous to previous one, comma input image, comma target Trendiest dot repeat dot take steps. I will explain all these things. Generate image. I will explain those two, three codes that is from generate image. In generate image, we have passes the model with previous to previous one image and real. Model means whatever I have developed a generator, I will pass that to the generator image, and after that, previous two is the image, previous one is image and real. To the generator we will pass three images and we will get a predicted output, and the real output is means our original output. So we printed here as a current image, actual output and predicted output. So whatever image I got, that is a current image, respective ground truth, and whatever I got a output. After that, we done on a definition for train step, means a in single iteration what we will do. In single iteration we will do one forward propagation and another is a backward propagation. For forward propagation we will pass the input images to the generator. That is, we already generator part we have done. So in generator we will pass three images, that is a previous to previous one and image to for training. Whatever the output I got, I will calculate the loss for this using a custom loss function. I have developed a custom loss function that is a generator. It is a real as our ground truth, and the generator output means whatever I got from generator, that we will calculate the loss for this, and I will got one single value in a generator loss. So I will update that gradient by using some optimization function. So all those training variables we can update by using this gradient loss function. So this is for a single iteration, means a single one forward propagation and one backward propagation. It completes one iteration. So we will iterate this image, this process for few thousand iterations. For that purpose, we have developed one uh, another definition. That is a definition fit is equal to trendiest. In trendiest, what we get means trend data structure, data set, test data sets, and how many steps we want to iterate, that you can print. You have to type here. So first we will take one sample image from test data set to see after a few iteration what I will get a output. For that purpose, I will put here as a iteration, and this is for train data set. So I will pass generator to all three images, whatever that previous three one image to the generator. So I will type that also. Now I will pass to train step, because in train step I have already mentioned the generator and it will back propagate also. So I will pass directly these three images to train step and target also. So it will be back propagate using this. So how many steps I have at that time, it will be iterate and it will give a output. So for each and every iteration I am showing here as a image. So we will put here as a, suppose if step is equal to 10, if step model divided by 10 equals to 0, then and then it should be display the generated image. Like this we will do one setting, otherwise it will show all the times. Generator x, okay. After that we will directly call fit function, in which train dataset, comma test dataset, comma number of steps. How many? Here as a steps. C. That is spelling mistake. Train step missing one required position argument. Okay. In train steps, I have no need to step function. Training data spelling mistake is there. Some spelling mistakes are there. So getting errors because of spelling mistakes. So just I am changing that only. It is a trainable variable, not training. Trainable variable. So we will one more time we will look out this code once. First, we have imported OS library and unzipped all. I have downloaded the data highway.zip and uploaded to the collab. And after that, I have unzipped my folder. After unzipping, I have two images, two folders. I have in a highway folder. So that is a input, and another one is a ground truth. So all these inputs and ground truths are listed out in a one variable and concatenated three images from input folders. That is a previous one and before previous and current frame. All these three frames are concatenated with a current ground truth. So all four images are concatenated and writed in a train folder. So that train folder we have done read all the images by using these load functions in data sets. And after that, I have normalized the images, load image, train data set, test dataset. I have done generator for train dataset and test dataset. After that, we have done one generator model, whatever that is a generator model that is for upsample, downsample, and this is the generator model. We printed here a summary for generator model. We plotted here a generator model, and we check the output for generator. Means we are passing three input images, and whatever the output we are getting, that we are shown here and displaying three images. That is a current input image, target image, and a predicted output. So using that, after that I have done one train step function in which we have done one forward propagation by using by passing the three images to the generator and calculating loss and back propagating it, get the gradient, and we are updating by using optimization functions. And we are done a fit, we have done one fit function, that is depth fit train data generator dataset, test dataset, and test 1000. All those images we have tested, and this and getting this we are training this. So for 10 step it is taking much more time, so I am stopping this and I will put step. Now it will need to will show now images because of network issue or some issue. It is not stopping this code. It is restart runtime, means I have to run again from scratch. So you can try it, and this is done for today. Hello, sir. Hello. Hello, ma'am.
Hello, hello, Gopi.
Uh, this is done for today.
Hello.
Hello.
Uh, Hello, Kuldeep. Am I audible?
Yes, yes, yes.
Okay. So thank you so much, Kuldeep, for such a great lab session today, and thank you all participants. Uh, so I think now we should leave. So thank you so much, participants, and good night. Thank you very much.